All right, everybody, we made it to the proof section. Yay! We are so excited to do these proofs. We're going to cheer every time we get to a new one. Number 25, let's go. Fill in the blanks for each proof. We've got this, we've got this, we've got this. This is a 2-column proof. Here are my statements. Here are my reasons. They have some of the statements filled in, some of the reasons filled in. And so here's the good news. In order to solve a problem, you have to be given a problem. So how do I know what to start with? You start with the given. You could copy paste this bad boy right here. Boom. What is the problem we are trying to solve? It is going to be 2 times x plus 5. We're just going to copy paste this. Plus 6 equals negative 4 plus 6x. That is what I'm trying to solve. How do I know that? What's the reason for that? Because it was a given. It's a given. Those are free points, y'all. Free points. Okay? What am I ultimately trying to prove? I am trying to prove that x is equal to 5. So we already know the answer. What we're trying to do is to explain the process of how to get there. So yes, x plus 5 is going to be what I'm ultimately trying to prove. X equals 5. I'm sorry, so I'm just going to copy that right there. You're not going to write prove next to it. Please do not do that. There should be a mathematical reason that x is equal to 5. We're just trying to show people our mathematical process along the way. All right, so they filled in the next statement. How did they go from 2 times x plus 5 to all of a sudden it's 2x plus 10? How would they get there? So what you're doing when you're looking for a reason right here is you're saying, how did I go from step 1 to step 2? What happened to get me there? Well, what did they do to get me there? They distributed. They used the distributive property. That distributive property would allow me to distribute the 2 to the x and the 2 to the 5. So what is 2 times x? It's 2x. What is 2 times 5? It's 10. Okay, so that's our distributive property. All right, so then it says to simplify. Okay, so this is going to either be simplifying or another thing you could say is you could also call this to combine like terms. Okay, we're going to combine our like terms. So we're going to clean up the left-hand side of the equation by putting our like stuff together. We're going to clean up the right-hand side. Another way to say that is to simplify. So what can I put together on the left? 10 plus 6 is on one side of the equal sign. So that becomes 2x plus 16. I just put together the 10 and the 6. I simplified that. And then there's nothing to put together on the right-hand side. And so that just stays negative 4 plus 6x. Okay, so we combined our 10 and our 6. Okay? All right, and then what did they do? They want to know, how did you get from here to here? That's what you're looking to put for the reason. How did I get from 3 to 4? Well, it looks like I had a 6x on this side and a 2x on this side, and then all of a sudden, they moved the 6x over by subtracting, okay, because they crossed the equal sign. So that's going to be a property of equality. It's what they did to both sides, and they subtracted. So that is going to be our subtraction POE. They subtracted the 6x from both sides. Subtraction, property of equality. All right, and now they tell us we're going to use subtraction a second time. Notice that was done twice. So what are they subtracting? I would need to subtract, to get the x by itself, which is what they're ultimately trying to do, I would need to subtract 16 from both sides. So what's my next statement? My next statement is going to read negative 4x equals negative 4 minus 16 more is negative 20. So again, that's the subtraction property of equality. That's how I got from step 4 to step 5. So then how do you get from step 5 to step 6? That's the reason we're going to put right here. That's our last reason. Well, how do you go from saying negative 4x equals negative 20 to x equals 5? What would you do to both sides? We would divide by negative 4 on both sides. Because when you do negative 20 divided by negative 4, you get positive 5. So that is going to be our division property of equality. That's how we got to x equals 5. Divided by negative 4 on both sides. And that is our first proof for number 25. Yay, proofs. All right, let's look at number 26. All right, we can rock this, friends. What is given to us? So just like before, we're going to copy our given in. But this time, they already have it written out for you. It's already copy-pasted into the proof. What do we put for the reason? That reason is going to be because it was given. Again, if we're going to solve a problem, we have to be given a problem to solve. Ultimately, this time, they tell you what you're trying to prove is HJ equals 18, which is already listed there for you. So what we're trying to do is figure out how do I start with the yellow and end at the pink, and we're going to explain our entire process. So how do we know in our second step that h to I, which is pink, plus I to j, which I'm going to do in green, is equal to the whole thing, h to j, 7x minus 3? That is going to be one of our segment postulates. That is going to be our segment addition postulate. It says that the smaller pieces of a segment add up to the whole. So the segment addition postulate. Okay. Does it in letters. And then it allows you to actually go through and substitute in. So it's kind of like when you're playing basketball, you can have people sub in for you, or volleyball or football. The person that you're going in for has to come out of the game. So those sub in. Okay, so those are expressions we get to sub in. What is it called when you sub? That is called substitution. That is our substitution property of equality. We're subbing things in. And then they do all of the statements for us here. It looks like they're doing some stuff on the left-hand side of the equal sign. The right-hand side of the equal sign stays the same. But all of a sudden, we go from having 2x and 3x to 5x, and then 6 minus 3. 6 minus 3 is going to give me 3. So what did I do there? I combined my like terms. And simplify or combine your like terms. Put the like stuff together. Okay? Don't like that E. Boom, better. All right, so then we're having to follow their thinking, so not necessarily how you would solve this, but how they solved it. It looks like they had a 7x on this side and a 5x on this side, so how do we get from step 4 to 5? They subtracted 7x from both sides, so minus 7x, and that's what gave you the negative 2x. That would be called the subtraction property of equality. They subtracted 7x from both sides, and then to get the x by itself, they'd have to subtract 3 from both sides. So again, another subtraction property of equality. And so if negative 2x equals negative 6, how would I get x by itself? I would divide both sides by negative 2. What is that called? Negative 2. Oh, by negative 2. What is that called? That's our divpo. That is our division property of equality. So a proof is like an annoying younger sibling being like, but why, every step of the way when you're trying to solve. If it just said solve for x, we would be done. But now we know what x is. We want to find that h to j is 18. So which color is h to j? H to j is yellow. So what was the expression we had for hj? 7x minus 3. So what we can do now is it was 7x minus 3, but now that I know that x is 3, I can plug that in right here. So I can plug in 3. What is it called when you plug things in? That is called substitution. There's a lot of T's in this. Substitution. Are there 3 T's? Substitution. So that's our substitution property of equality. I can plug that into an equation. I can substitute into an equation. And then we take that right-hand side. Since we're only doing it to one side of the equation, that is going to be simplify. Whenever you do 7 times 3, you get 21, and 21 minus 3 is 18. So I simplified just one side. Hj equals 18 is what I was trying to prove, and that is how I got there. I will do a new video for the next proof. Yay, proofs!